Let us solve the mystery around molecules and compounds in this particular video. Welcome to our series on science. We are going to explore many topics which are related to middle school students. The whole idea here is to guide, especially teachers and instructors, so that they can provide absolutely correct and precise information to our students. We are going to explore molecules and compounds and details. We'll see when to use the word molecule and when is it appropriate to use compounds. In short, we'll cover the headings: what are molecules, what are diatomic elements, what are multiatomic elements, what are compounds, differences between molecules and compounds, allotropes of elements, and then a small activity to make molecules from the given atoms. Enjoy the journey of learning. I am Anil Kumar. Welcome to our very interesting series on science. There will be very few videos, but in each video, we are going to discuss some major points which we need to clarify to many students. So, here now let's look into what are molecules. So, what do you think are molecules? Well, as you know, molecules are the smallest particles which participate in any chemical reaction. And these molecules are actually made up of atoms. So, molecules could be formed by two or more atoms, right? So, first thing is they can be formed by two or more atoms. Atoms on their own are not stable. So, atoms combine to form molecules, which is a stable state where we have a complete characteristic of that particular molecule. Now, when I say two or more, then these atoms could be of same element or different elements, right? So these atoms could be of same type or different type. So when I say same or different, we are concerned about the atomic number which signify the characteristic of that particular atom. Now when I say same elements, then you think about atoms like hydrogen combining together to form molecule of H2, O2, right? Cl2. So many such gases they combine. So these are called diatomic elements, right? So these are two atoms of the same kind. We have a very limited number of these. We'll have examples of diatomic atoms in the following slide. Now, atoms of different elements could be NaCl, right? For example, salt, the common salt, where one atom of sodium Na combines with one atom of chlorine to form sodium chloride, commonly known as salt. Perfect. Now, this is also diatomic. Diatomic means two atoms are combining to give you a molecule, right? You could have sulfuric acid, H2SO4. Now, in this particular case, you see there are two atoms of hydrogen which combine with an atom of sulfur and four of oxygen. Similarly, many other, right? So you can write many examples of molecules which are combining to form, you know, atoms combining to form molecules. Now, these, which mentioned here, have their characteristic chemical properties. And whenever we want to further react, then they can further react with one another as molecules. You get the idea, right? So that is what it is. So when we have something like this as mentioned here, then these are the molecules. Now, molecules formed in this fashion, when the atoms are binding together, this bond can be of different kind. When they are of the same kind, then always the bond is covalent. However, when different atoms are combining, the bonds could be covalent or could be because of ionic interactions. Now, look here, I'm using the word ionic interactions instead of ionic bond. Now, it has a meaningful approach because ionic interaction is like Na, if you see ion wise, is positive, combines with Cl negative. Positive really means that electron in the outermost orbit of sodium was given to chlorine, which had 7 electrons in the outermost orbit. So both came to their stable stage by one giving away and the other taking one extra. So once an electron is gained, you get negative charge, and when you lose an electron, you get a positive charge. So that is ionic interaction. In case of covalent bonds, when I have to show the bonds, for example, I have to show hydrogen combining with hydrogen, we draw this line, which is a covalent bond. So, whenever bonding is there, we represent it with a line. Whenever ionic interactions are taking place, it makes more sense to write NaCl as shown here rather than NaCl, right? So, this is incorrect. And therefore, we do not want to use the term ionic bond, but ionic interaction is a better term to be used. So I think you got fairly good idea about what are molecules, right? Now, in this molecules, we talked about molecules formed by same type of atoms, right? Now, we will take some examples. Let me just share with you diatomic molecules with these examples. So we just discussed that diatomic molecules are formed by bonding of two atoms. Di means two. Many compounds are diatomic like NaCl, HCl, KBr. Diatomic elements are pure elements formed by bonding of two similar atoms. So see there's a term diatomic elements, right? And diatomic molecules. Diatomic elements, when we are talking about, we are saying pure elements formed by bonding of two similar atoms. So all the gases which I am going to show here, they are 7 in number, and these are all diatomic elements. So hydrogen will exist in the form H2, covalent bond between hydrogens. Similarly, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, right? Now you can use this acronym, which is very popular. Have no fear of ice cold beer. So the initials hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. So that ways you can easily remember the diatomic molecules. Now let's look into some other multi-atomic elements. So when we talk about elements, we are worried about same kind. For example, phosphorus can exist in many different forms. So P4 is one of them. Four of the phosphorus atoms combined together. It is the white phosphorus, right? This is the white phosphorus. Now, these forms can change with heat and even with sunlight. In case of white phosphorus, it can become red phosphorus, another allotropic form. We have ozone, for example, right? So here you see there are three atoms of oxygen, same type, right? Sulfur has many allotropic form. S8 is one of them, for example, right? So these are all with multi-atomic elements, right? So it is not just the diatomic which we have. There are many multi-atomic elements. Now let us see how do we name molecules, right? So as you know, molecules are formed with two or more atoms, and this is always in a fixed ratio, right? So scientifically, molecules are written in specific formula using symbols of each binding atom along with the number. Number is a subscript, you can see there. So number tells how many are there of each atom. So Fe2O3, which is ferric oxide, means 2 iron, Fe is iron, and 3 oxygen atoms combined together in this ratio, Fe2O3. Similarly, H2SO4, sulfuric acid, in which we have 2 hydrogen, 1 sulfur, 4 oxygen atoms. So these are the molecules, right? So when we have a reaction between the molecules, we get a new molecule, which is shown here, right? Now, whatever we have learned about molecules so far, it is good time to kind of reconcile. So here in point form, I've given you what are molecules. Molecules are formed when two or more atoms bond together in a fixed ratio. So two or more, correct? Molecules can be made from same kind of atoms or different kind of atoms. So same kind, diatomic, we saw seven of them, right? And then we also have many examples like phosphorus P4. Molecules are formed with covalent bonds or ionic interactions. This is important. So there are, apart from covalent bonds, there are many other kinds of bonds. So sometimes we say coordinate bonds, ionic bonds. So what I'm trying to do here is the word ionic interaction includes them all. So that is the beauty of this particular word. Molecules can be diatomic, polyatomic, or in large chains like DNA structure. So DNA protein structures are all molecules. There are very, very large chains, right? Molecules can exist by themselves and are often stable in contrast to atoms. So, this is another difference between molecules and atoms. Molecules are stable, atoms are not. However, there is an exception to this, right? So, inert gases, right? That is an exception, right? Argon, krypton, neon, all those inert gases, helium, are stable as such, right? So, except for them, most of the other atoms are not stable in their atomic form, where only the noble gases, gas atoms are stable, right? Molecules are the smallest, electrically neutral, fundamental units of taking part in any chemical reaction. So, this is the most important definition where molecules are the smallest, they are electrically neutral. And these are the fundamental units which participate in any chemical reaction. Perfect. So these are very good points to understand. Now, from here, can you tell me what are not molecules? Can you give me example of things which are not molecules? So the key words to look into are that they are electrically neutral. So if we talk about ions, right, it could be many kinds of ions, hydroxyl, Ions, for example, they are not molecules, right? So let's have some examples of what are not molecules, right? Elements as such are not molecules, correct? Right? That is one group. So let's say copper, gold, silver, right? Iron. These are not molecules. Then hydrogen ions, right? So we could have many ions, right? Sometimes OH, right? So NaOH. So hydroxyl is also an ion, right? So Na, right? And OH, right? So we have different kinds of ions in any reaction. They are not molecules, they are ions. Alloys are not molecules. For example, bronze, which is an alloy of mixture of copper and tin, it is a mixture, right? It is not even a compound, or it's a mixture. Because when you form bronze, apart from copper and tin, many other substances are added, and their ratios is not constant. Okay, now here we will have a second look at how do we write the molecules. Scientifically, molecules are written in specific formula using symbols of each binding atom along with number subscript. Number tells how many are there of each type, right? For example, S8, right? So it is, as we said, allotropic form of sulfur. Cyclooctasulfur, 8 sulfur atoms, right? NH3, also known as ammonia, has 1 nitrogen and 3 hydrogen atoms. Ammonia does exist in natural form. So there are bacteria which do nitrogen fixation, and ammonia is a kind of poisonous gas. Highly used Ammonia is highly used in fertilizers. Fe2O3, ferric oxide. So iron as such is very reactive. So with oxygen it forms many different kinds of oxides. One of them is ferric oxide Fe2O3, where we have two iron atoms combining with three oxygen atoms. So you can see in a molecule always there is a fixed ratio in which atoms will be combining. Sulfuric acid, H2SO4, is the strongest acid which we have, where two hydrogen atoms combine with the sulfur and four hydrogen oxygen atoms, right? H2SO4. So subscript H2, two hydrogen atoms, S1 and oxygen 4. So that is how we write the formulae for molecules. Perfect. So I think you have clear idea about what are molecules. While describing molecules, a couple of times I use the word compounds. Now let's see when to use the word compounds and when not to use it, or when to use only molecules. This is what we have to understand, and that's the major part of this video to understand. So, for that, I looked into the history of these words, how they have come about. So, from Wikipedia, I found a reference which says that Robert Boyle in 1661 used unit of bonded atoms, that is molecules, what we call now as molecules. This word molecule was not used by him but was implied. But the word used by Robert Boyle was cluster of particles, where particles are the atoms and cluster of particles is what is referring to, right? And he also used the word compound in his own way. So the reference how this has come is chemical changes result from rearrangement of clusters. So whenever a chemical reaction takes place, then the rearrangement actually gives the new substance. So that is what is being tried. And the compound is that compounded bodies perfectly mixed bodies. So that was kind of reference to these words early on in 1661. However, the way we use today molecules and compounds was effectively used by Amedeo Avogadro. Yeah, you must have heard about Avogadro's number. So he created this word molecule in 1811. It is the smallest particle of gases. So what he discovered that the smallest particle of gases are not necessarily atoms. So this was his discovery that smallest particle of gases are not necessary atoms. And we saw diatomic molecules. You get the idea? So those seven diatomic molecules is what Avogadro is referring to. They normally do not exist as atoms, right? But are made up of certain number of atoms united by attraction to form a single molecule. So that is the use of the word molecule in the sense we are using it now, right? The whole credit goes to him. So Avogadro's constant, as you know, is 6.02 into 10 to the power 23 per mole. We're not getting in details at this level where high school students will definitely know about it. But since we are restricting ourselves to middle school and slightly extended, we are giving you a topic to explore further. So he related these all these terms, number of molecules with mole and weight or mass in grams, right? So that's kind of very important to understand. So with that, now let us try to understand what are compounds, right? So let's think what are compounds, correct? So basically, what we say about compounds is that here again, compounds are formed by two or more atoms of different kind. You understand? So the eight diatomic molecules will not be considered as compounds. So this is kind of very important. So two or more, yes, that is common, but they are formed with different atoms, not the same kind, right? So diatomic compound could be NaCl or salt. So this is I write this as salt. Now purposely I'm using the word salt here. The common name I could use sodium chloride, right? Or I could use sodium chloride. Okay, so when we use the term salt or sodium chloride, we really mean compound. Now, where should we use the word compound instead of molecule? Because NaCl was diatomic molecule also, right? It is still a molecule, correct? But we can call it a compound. So the distinction which I am going to make here is that when we are talking about bulk of material, you understand? So when we are talking about bulk of material, then we refer to compound. But when we are talking about a unit, the smallest unit, in that case, we talk about molecule. How are they different? Well, when you have a reaction, chemical reaction, right? In that case, molecules are interacting. You understand? So, whenever we're talking about chemical reactions, in that equation, all are molecules. Molecules are interacting. But a general form, where we talk about bulk, we'll say is a compound. For example, if I say H2O, what I'm trying to say is a molecule of water. But when I say water, it is a compound. You understand the bulk of water. You get the whole idea. So that is what I think is a good way of referring to an item, a substance, as a molecule or as a compound. Correct? So, with that in mind, let's summarize the major differences between molecules and compounds. So, before that, let's see what are compounds. So, these are kind of your notes, right? Compounds are formed when two or more atoms of different elements are chemically joined together. Now, when you're joining them, this could be covalent bonds or ionic interactions, right? All compounds are molecules, but all molecules are not compounds. You get the idea? All compounds are molecules because molecules are also formed when two or more atoms of elements combine, right? If they are different, we can call them compounds also. But if they are same, we cannot call them compounds. That's the whole idea. So, oxygen, hydrogen, ozone consists of only one type of atom and are so not compounds. So, that is clear distinction between the two. Right? So, normally, molecules written in bulk form like water, glucose, ammonia, sulfuric acid are treated as compounds. So that is a general way of looking at it. So here's a note for you. Molecules can be made from same kind of atoms or different kinds of atoms, but compounds are always made from different kinds of atoms. So that brings us to the exercise. We have learned about molecules and compounds. I hope you have enjoyed this journey of learning. Now, to end this, there are two problems which you may like to do. So, make a Venn diagram to show molecules and compounds. So, this is one of the exercise. I like you to make a Venn diagram to show what are molecules, what are compounds, how will you represent them on a Venn diagram. That is what we like to see. Well, I hope you have enjoyed this journey. You can always send an email to globalmathinstitute@gmail.com to learn directly from us. And if you have any questions, feel free to post your questions, right? Here's your second question, which is more of activity. So I like you to, we've given you some atoms, right? So there's nothing is to the scale, just some circles with name of elements. So first one, sodium, hydrogen, iron, chlorine, sulfur, oxygen, and zinc. So with these, I like you to form some molecules, right? So as an exercise, try to form molecules using these atoms, as many as you can, right? As many as you can. And for each, write down a scientific formula as we discussed. If you know the name also, how do we write the name? Explore and write down the names also for them. Perfect. So I hope with this we can end this particular class. Look for our videos on exploring science and understanding it better. Feel free to ask your questions. In case you directly want to learn from us, send an email on globalmathinstitute@gmail.com. Thanks for your time and all the best.